Okay, thank you all for attending. This is our monthly webinar on power monitoring products. Okay, here's our agenda for today. First of all, we're going to go over how does a power meter work and what does it do. Then we'll go over ICP DAS's product selection guide and power meter products. We'll go over some applications for power meters, including how to monitor energy usage, which can save money, and how to implement power meter products with SCADA systems. ICP DAS was established in 1993. Our headquarters is in Hsinchu, Taiwan, and ICP DAS USA was launched in 2001 to support the North and South American markets. Our products are ISO 9001 and RoHS compliant, and we are a Microsoft embedded partner. First of all, how does a power meter work? A power meter measures voltage and current in real time and calculates power while keeping track of power consumption and other power-related data. Our power meters are able to allow HMIs, PLCs, PCs, and SCADA systems to access this data. The data is accessed using one of three protocols: Modbus RTU, Modbus TCP, and CANopen protocols. Each model, you need to select which protocol you want. So there's various models for each protocol. Our smart power meters monitor the energy usage, track the true RMS power measurements, and have relay outputs for triggering alarms or turning equipment on and off based on conditions set forth in your SCADA system. We can easily connect to most PLC and SCADA systems using the protocols mentioned before: Modbus RTU, Modbus TCP, and CANopen, which are very popular in the industry. And our products are made for industrial applications and are DIN rail mountable, most of our products. The three protocols again: Modbus RTU and Modbus TCP, which are two of the most common protocols. Modbus RTU being over serial communication, RS-485, and Modbus TCP being over Ethernet, and CANopen protocol is communicable over CAN bus. The measurements, or the parameters shown here, are the measurements provided by the power meter. The data is updated every 1 second, so if you poll the data, you can get new data every 1 second of a poll. They include the RMS voltage, current, active power, active energy, apparent energy, power factor, and frequency. How to choose the correct power meter for your application. First, you want to know the number of channels you're measuring, whether you want one channel or many channels. Then you need to know what type of channels are required. You need to know the input voltage range, whether it's single or three-phase voltage you're measuring. And let's see, we'll go over CTs a little bit, but you need to know CT size, and if you need a secondary CT, which we'll also go over shortly, and wire size. And thirdly, you must need to know the protocol that you want to communicate the data with, whether it be Modbus RTU, Modbus TCP, or CANopen. For our power meters, we have three-phase systems and single-phase systems. This is the table which shows the breakdown of the part number for our three-phase power meters. The PM3133 is a series for three-phase power meters. The next three digits determine the CT size and the maximum current measurable. The P, whether it's there or not, determines whether there's a secondary transformer for measuring larger current output. And the final characters determine the communication protocol that the power meter is designated for. Without anything at the end, that would be RS-485 Modbus RTU. If there's a CPS, that's CANopen protocol, and MTCP is Modbus TCP. Here's a table showing most of our current models. Note the very first one has no protocol listed at the end, so that's Modbus RTU version. And without the dash 100 or 160 or 240, that one just has or has no CTs that are included. We'll go over a little bit more details on that shortly. And then we have our Ethernet Modbus TCP versions and our CANopen versions for our three-phase power meters. And note that the inside diameter of the CT is shown there in the table as well. Okay, next, this is the part number breakdown for our single-phase models. PM311 is the beginning part of the part number. Then the next character, number of channels, whether it be 2 channels or 4 channels. And then CT size with measurement and protocol lastly. Most of these are very similar to our three-phase ones, just these are for single phase. So again, the first section is Modbus RTU, second section Modbus TCP, and third section CANopen protocols. And we have various models with both 2-loop and 4-loop versions, and CTs are included with all of these models. For applications where the maximum current will exceed 400 amps, we have the option of with models with a secondary CT. The secondary CTs can be wired as shown here, where the primary CT measures the full current, and then it's broken down by a secondary to give the higher current with a second CT. You can let's see. These are what our CTs, our standard CTs, look like. They're included with the power meters, and they're clip-on CTs to make for easy installation. Pay attention to the diameter of the opening when choosing the correct power meter as well, because sometimes the wire thickness may play a part in the CT size as well. This just shows a wiring example of how to install the power meter. So you wire power into the power meter, and then you clip on the CT. So you don't need to disconnect or wire the CT in. You just clip it onto an existing wire, and it makes for easy installation as shown here. Okay, we also have models which do not include CTs. These are if you want to use your own CTs. Our standard models do not use standard CT inputs, so you want to be sure to select the appropriate version which has the CT input type correct. We have 3 models available. The third one is actually available as well. So we have a Modbus RTU, Modbus TCP, and CANopen protocol version. These are for 3-phase systems, and these are for, again, applications where no CTs are included, so you can either use your own CTs or purchase them separately. For these, customers must use their own CTs. The CTs must be the 5-volt DC type. Our other models come with the CTs factory calibrated for the module, but these do not. So the benefit of the ones with the CTs are that it's for standard current and amperage, and they come factory pre-calibrated. If you want the ones where they do not come with CTs, you need to supply your own, but they're not factory calibrated as well. Okay, for higher current versions, we also have our new series, which has Rogowski coils, which are rope-style CTs as shown here in the picture. Again, they're broken down based on protocol and maximum amperage. So note these can go up to 2,000 amps and are for 3-phase systems. If you have like a large apartment complex, shopping mall, industrial mall, the PM4324 is a great solution because it can accept either 8 three-phase circuits or 24 single-phase circuits in one module. So all these channels can be pulled using a protocol, and everything is wired into the single module as opposed to the other modules which require, which would have like 2 channels or 4 channels. This one can accept up to 24 in one model, and these also come with CTs for the most part as long as you choose the correct part number. Here's a breakdown of our part numbers for the PM4324 series. Again, they're the 24 CT versions, and they're broken down into various protocols and various maximum amperage. So you want to choose the model which has the highest amperage that your application will be given, or using rather. And we also have the very top model, which does not come with CTs. So if you want to provide your own CTs, you can choose the first model. If you want to display the values for a single power meter, we also have versions of our TPD series which come with power meter display programs as shown here. And these are available only for the Modbus TCP and Modbus RTU versions. Let's see, we have the gray version on the right side, which is our VPD 173-PM, and the TPD 703-PM on the left side. They're both available in 7-inch and 4.3 inches, and they come with the power meter profile program that's shown here if you have the -PM. You can also order the touchpads without the PM mod or PM designation, and you can create your own programs to communicate to the power meters, but these just make it easy and have the programs pre-programmed in there. Some applications that power meters are used in: energy monitoring, energy management, various SCADA applications, load shedding, industrial complexes, shopping malls and office buildings, along with apartment complexes, factory. They're used for failure detection, emergency services, like say if power is lost in a building or something, home automation, machine control, and they're very widely used in solar energy, wind farms, and hydroelectric monitoring as well. Here's some benefits of the ICP DAS product line. First of all, with our clip-on CTs, it makes installation very simple. So if you do choose the models with the CTs included, the clip-on versions are very popular and make installation so simple that people like it a lot. The CTs are factory pre-calibrated if they are the clip-on types, so you get better results in the beginning. We have models which customers can use to supply their own CT if they already have their own CT or need a larger CT. We have models which allow a secondary CT for larger currents. The new RCT or Rogowski models can also be used for larger currents. And we have our PM4324 series, which accepts 24 CTs for either 24 single-phase circuits or 8 three-phase circuits. And we use Modbus TCP, Modbus RTU, and CANopen protocols to make sharing the data very easy to your PLCs or software packages or other devices in your network. Additionally, the power meters can be used with as data acquisition modules. So if you have other ones of our data acquisition modules, you can simply add the power meter and have power parameters also measured along with your other data and controls. The power meters can be used with competitive manufacturers who do not have power meters for data acquisition. The power meters can connect to other PLCs, both Modbus RTU, Modbus TCP, or CANopen. It doesn't necessarily need to be ours, so it works very well with third-party software and hardware. And we also manufacture power meter concentrators. Power meter concentrators can be used to collect data from many power meters and allow the one device to be polled. So for instance, if you had a large facility where you maybe had 20 power meters, you can break it down into a few power meter concentrators, where the power meter concentrators will poll the individual power meters on a periodic basis, and then from your SCADA system or PLC system, you can just poll the power meter concentrators. There's a slide in a few. Actually, here's a picture of our power meter concentrators, our two versions. The PMC 5151 is our non-display version, and the PMD 2201 is a 7-inch display which shows the parameters. See, I think, okay, this slide. So the idea behind the power meter concentrators is it would simplify the polling for the master device. So instead of polling multiple or many slave devices, the power meter concentrator will poll a branch of the power meters and save the data into one module. And then your master device, or in this case, the SCADA system at the top, could poll the individual power meter concentrators to speed up the data acquisition and lessen the burden of the processor of the master. Some features for the PMC modules. There's no software required to configure. They're configured using a web browser, like Internet Explorer. Simply set the IP address of the power meter concentrator and then log in to the web through the web browser to configure the module. Multiple connections can be made to a single power meter concentrator, and it allows addition of an XW board, which can give additional outputs. Like for instance, if you wanted to trigger additional alarms, you can add a relay board. Let's see, our power meter concentrators also communicate with SCADA systems and IoT systems with real-time power data, and they support Modbus TCP and Modbus RTU protocols for this. And some of our power meters support SNMP and MQTT protocols for communicating to IoT systems. And the power meter concentrator also has a data server which can show historical data stored in the SD card. And it will work well with our InduSoft power meters and panel PCs for SCADA applications and monitoring. The power meter concentrator can also create reports. Here's a sample of some monthly reports that are configurable in the web browser. The top shows the menu of the power meter for the configuration, and the bottom shows the resulting report in a PC. Let's see, it also provides for scheduling features. So for instance, if you wanted to schedule like power to be turned on for say a school or something during the school year, but program in holidays and minimum days to minimize electricity usage, and for lighting controls, and also set like turn on the lights at night so that people can see in the dark when needed, and turn off the lights during the daytime to save energy. And this is all done using if-then-else rules in the power meter concentrator. Here's 3 of our power meter concentrators that are for IoT. The PMC 5231 is Ethernet based, and the one at the far right has cellular communication. These are great for communicating to IoT systems. Here's a few applications for power meters. In this application, let's see, it's sending an alarm message or warning message based on power usage through emails, SMS, or to MQTT system in real time. So it has the power meters connected to the individual equipment, and the power meter concentrator will send the SMS alarms and also periodic data if you configure it to do that. The power meters and power meter concentrators are also used in all of these applications, everything from security to transportation logistics, medical and healthcare, and industrial energy and solar energy production. For the PMC selection, these are the power meter concentrators with displays. We have a 7-inch version and a 10-inch version. The part number is at the top, PMD 2201 for the 7-inch and PMD 4201 for the 10-inch. These provide all the same functionality of the PMCs, but have a built-in display. So instead of going through a web browser, you can just purchase one of these and configure everything through the touchscreen interface. Let's see, here's just a simple application diagram showing a standard application. Let's see, the power meters at the bottom measure the power. The touchpad at the top is used to display the data or pull for the data, and the TGW module shown there just passes the data to the SCADA system. Okay, does anyone have any questions for this topic? If you do, type in the chat box and we'll be happy to answer any questions you have. Okay, if no one has any other questions, then we'll end this webinar, but we'll see you next month for our next webinar. The topic will be announced in our monthly newsletter, and if you have any suggested topics, please feel free to send us an email, and we can possibly add it to the schedule if the product is popular enough, or if you have individual questions about any of our products, please feel free to call us anytime. Thank you.